Welcome to read questions and answers for General Ham Radio Class License. If it is helpful or not, please let me know in the comments section. Also, let me know that you passed the test. I wish you good luck. This is Chapter 9. Sub-element G9, Antennas and Feed Lines. Section G9A, Feed Lines, Characteristic Impedance and Attenuation. Standing wave ratio, SVR calculation, measurement and effects. Antenna feed point matching. Question G9A01. Which of the following factors determine the characteristic impedance of a parallel conductor feed line? Answer: the distance between the centers of the conductors and the radius of the conductors. Question G9A02. What is the relationship between high standing wave ratio SVR and transmission line loss? Answer: high SVR increases loss in a lossy transmission line. Question G9A03. What is the nominal characteristic impedance of window line transmission line? Answer: 450 ohms. Question G9A04. What causes reflected power at an antenna feed point? Answer: a difference between feed line impedance and antenna feed point impedance. Question G9A05. How does the attenuation of coaxial cable change with increasing frequency? Answer: attenuation increases. Question G9A06. In what units is RF feed line loss usually expressed? Answer: decibels per 100 feet. Question G9A07. What must be done to prevent standing waves on a feed line connected to an antenna? Answer: the antenna feed point impedance must be matched to the characteristic impedance of the feed line. Question G9A08. If the SVR on an antenna feed line is 5:1 and a matching network at the transmitter end of the feed line is adjusted to present a 1:1 SVR to the transmitter, what is the resulting SVR on the feed line? Answer: 5:1. Question G9A09. What standing wave ratio results from connecting a 50 ohm feed line to a 200 ohm resistive load? Answer: 4:1. Question G9A10. What standing wave ratio results from connecting a 50 ohm feed line to a 10 ohm resistive load? Answer: 5:1. Question G9A11. What is the effect of transmission line loss on SVR measured at the input to the line? Answer: higher loss reduces SVR measured at the input to the line. Section G9B. Basic dipole and monopole antennas. Question G9B01. What is a characteristic of a random wire HF antenna connected directly to the transmitter? Answer: station equipment may carry significant RF current. Question G9B02. Which of the following is a common way to adjust the feed point impedance of an elevated quarter wave ground plane vertical antenna to be approximately 50 ohms? Answer: slope the radials downward. Question G9B03. Which of the following best describes the radiation pattern of a quarter wave ground plane vertical antenna? Answer: omnidirectional to azimuth. Question G9B04. What is the radiation pattern of a dipole antenna in free space in a plane containing the conductor? Answer: it's a figure 8 at right angles to the antenna. Question G9B05. How does antenna height affect the azimuthal radiation pattern of a horizontal dipole HF antenna at elevation angles higher than about 45 degrees? Answer: if the antenna is less than half wavelength high, the azimuthal pattern is almost omnidirectional. Question G9B06. Where should the radial wires of a ground-mounted vertical antenna system be placed? Answer: on the surface or buried a few inches below the ground. Question G9B07. How does the feed point impedance of a horizontal half-wave dipole antenna changes as the antenna height is reduced to 1/10 wavelength above the ground? Answer: it steadily decreases. Question G9B08. How does the feed point impedance of a half-wave dipole change as the feed point is moved from the center towards the ends? Answer: it steadily increases. Question G9B09. Which of the following is an advantage of using a horizontally polarized as compared to a vertically polarized HF antenna? Answer: lower ground losses. Question G9B10. What is the approximate length for a half-wave dipole antenna cut for 14.250 MHz? Answer: 33 feet. Question G9B11. What is the approximate length for a half-wave dipole antenna cut for 3.550 MHz? Answer: 132 feet. Question G9B12. What is the approximate length for a 1/4 wave monopole antenna cut for 28.5 MHz? Answer: 8 feet. Section G9C. Directional antennas. Question G9C01. Which of the following would increase the bandwidth of a Yagi antenna? Answer: larger diameter elements. Question G9C02. What is the approximate length of a driven element of a Yagi antenna? Answer: half wavelength. Question G9C03. How do the lengths of a 3-element Yagi reflector and director compare to that of the driven element? Answer: the reflector is longer and the director is shorter. Question G9C04. How does antenna gain in decibel I compare to gain stated in decibel D for the same antenna? Answer: gain in decibel I is 2.15 decibel higher. Question G9C05. What is the primary effect of increasing boom length and adding directors to a Yagi antenna? Answer: gain increases. Question G9C06. Which of the following is a characteristic of using a gamma match with the Yagi antenna? Answer: it does not require the driven element to be insulated from the boom. Question G9C07. What does front-to-back ratio mean in reference to a Yagi antenna? Answer: the power radiated in the major lobe compared to that in the opposite direction. Question G9C08. What is meant by the main lobe of a directive antenna? Answer: the direction of maximum radiated field strength from the antenna. Question G9C09. In free space, how does the gain of two 3-element horizontally polarized Yagi antennas spaced vertically 1/2 wavelength apart typically compared to the gain of a single 3-element Yagi? Answer: approximately 3 decibels higher. Question G9C10. Which of the following can be adjusted to optimize forward gain front-to-back ratio of SVR bandwidth of a Yagi antenna? Answer: all these choices are correct, which are the physical length of the boom, the number of elements on the boom, the spacing of each element along the boom. Question G9C11. What is a beta or hairpin match? Answer: a shorter transmission line stub placed at the feed point of a Yagi antenna to provide impedance matching. Section G9D. Specialized antenna types and applications. Question G9D01. Which of the following antenna types will be most effective as a near vertical incidence skywave NVIS antenna for short skip communication on 40 meters during the day? Answer: a horizontal dipole placed between 1/10 and 1/4 wavelength above the ground. Question G9D02. What is the feed point impedance of an end-feed half-wave antenna? Answer: very high. Question G9D03. In which direction is the maximum radiation from a VHF, UHF halo antenna? Answer: omnidirectional to the plane of the halo. Question G9D04. What is the primary function of antenna traps? Answer: to enable multiband operation. Question G9D05. What is an advantage of vertically stacking horizontally polarized Yagi antennas? Answer: it narrows the main lobe in elevation. Question G9D06. Which of the following is an advantage of a long periodic antenna? Answer: wide bandwidth. Question G9D07. Which of the following describes a long periodic antenna? Answer: element length and spacing vary logarithmically along the boom. Question G9D08. How does a screwdriver mobile antenna adjust its feed point impedance? Answer: by varying the base loading inductance. Question G9D09. What is the primary use of a beverage antenna? Answer: directional receiving for MF and low HF bands. Question G9D10. In which direction or directions does an electrically small loop less than 1/10 wavelength in circumference have nulls in its radiation pattern? Answer: broadside to the loop. Question G9D11. Which of the following is a disadvantage of multiband antennas? Answer: they have poor harmonic rejection. Question G9D12. What is the common name of a dipole with a single central support? Answer: inverted V. This is the end of Chapter 9 of Read Questions and Answers for General Ham Radio Class License. Please follow me for Chapter number 0.